I am glad you are here. Today, we will explore a simple but powerful idea from magnetism magnetic field lines. Magnets produce forces that we can't see, but magnetic field lines let us visualize these forces. In the next few minutes, we will learn what these lines are, how they behave, and what they tell us about how magnets interact. Are you ready? Let's begin. First of all, we are going to learn about magnetic field lines. So, what are magnetic field lines? Magnetic field lines are imaginary lines we draw to represent both the direction and the strength of a magnetic field. They are not physical objects, but they help us picture how magnetic forces are arranged in space. An important feature of these lines is that they form closed loops. Outside a magnet, the lines run from the north pole to the south pole. And inside the magnet they return from the south back to the north, completing the loop. As you can see in the figure that there are certain number of loops, and we can observe that these loops are closed loops. So we can say that magnetic field lines are imaginary lines used to represent the direction and strength of a magnetic field, and they are closed loops. In the next slide, you can see that there is a magnet and arrows showing the direction of the magnetic field. So it says that outside the magnet, the direction of magnetic field lines is from the north pole to the south pole. So now let's focus on direction. As we can say it in more detail that outside a magnet, the magnetic field lines always travel from the north pole to the south pole. That's why on diagrams you will see arrows pointing away from the north and toward the south. Inside the magnet, the direction is reversed. The lines go from south to north, so that every line completes a continuous closed path. So we can say that, or try tracing one of those loops with your finger on the screen to see the path. Do you observe it? Yes, we can trace the loops using our fingers by tracing it on the screen. Now let's focus on studying about the characteristics of magnetic field lines. Though we already studied about magnetic field and magnetic field lines, let's discuss more detail about the characteristics of magnetic field lines. Mainly there are three characteristics of magnetic field lines. The first one is magnetic field lines never intersect each other. Now imagine if two lines crossed. At that crossing point, the field would have to point in two different directions at the same time, which is impossible. So the lines remain smooth and separate. They never cross each other. This rule helps us read field diagrams correctly and prevents contradictory directions at any point in space. So the first point is that magnetic field lines never intersect each other. Okay, now look at this slide. Next, look at what happens when like poles, for example north facing north or south facing south, near each other. These field lines bend away from one another. As you can see in the figure that the magnetic field lines between the poles north and north of a magnet, it becomes that is the field lines bend away from each other. As you can see in the figure that two north poles are there, and when that magnet come close, the magnetic field lines bend away from each other. This bending lines tells us that the magnets are repelling. The lines spread apart because the magnetic forces push the field outward. This visual spread shows weaker attraction and stronger repulsion in that region. Now observe the unlike poles, north facing south. In this case, the field lines run directly from the north pole of one magnet to the south pole of the other. The lines appear neat and dense between the poles. That density indicates attraction. The poles pull towards each other and the field lines connect the two magnets smoothly. As you can see in the figure and in that slide, when unlike poles come close, the magnetic field lines go from north pole of one magnet to the south pole of the other. These are the main three characteristics of magnetic field lines. Next, you can see a figure in this slide, and there is a writing that the distribution of magnetic field line is more at the poles. Since the poles have more magnetic field lines, the magnetic field strength will be greater at the poles. Another important point, right? The magnetic field is strongest at the poles. Why? Yes, because the number of field lines per unit area, what we call the line density, that is highest or close to the poles. In that figure, you can see that iron fillings cluster more densely at the poles than elsewhere, which visually confirms that the poles are regions of stronger magnetic force. I hope you all understood what we learned today. Let's summarize our topic. Magnetic field lines are imaginary lines used to represent the direction and strength of a magnetic field. They are closed loops, and outside the magnet, the direction of the magnetic field line is from the north pole to the south pole. And then we learned about the characteristics. The first characteristic is magnetic field lines never intersect each other. And the second one is when like poles of two magnets come close, the magnetic field lines bend away from each other. When unlike poles come close, the magnetic field lines go from the north pole of one magnet to the south pole of the other. Hope you all understand about this. Now, let's check your understanding with 3 quick questions. Think of your answers. The first question is, what do you mean by the magnetic field lines? Yes, correct answer. Second question, how are magnetic field lines outside the magnet? Very correct answer. And final question, what are the characteristics of magnetic field lines? Very good. Now, it's time for a quick observation exercise. Find the polarity of A and B. Look at the two figures on the screen labeled A and B. Now I tell you some steps and try to do it yourself. Find the arrows on the field lines, first one. Then second step is identify which end of the magnet the arrows are coming out of and which end they are pointing towards. Remember these points and you will get the answer. Try to do it yourself. Hope you all understand it. Understanding magnetic field lines help us visualize invisible magnetic force. This is the foundation for many advanced concepts like electromagnets, electric motors, and generators. Thank you for watching. Continue exploring the wonders of magnetism. Thank you.